Hey there, this is Seth Schaefer from Team Just Cause Robotics, and today's video is all about AM32, the hot new 32-bit ESC firmware that's taking the combat robotics and drone world by storm. In the last year, it's become the predominant firmware used by most combat robot builders, and there are a lot of reasons I'll get into for that later on. But the most important thing that you need to know is that it runs on 32-bit microcontrollers on your ESCs, and it's fully open source firmware that's under active development right now, with a team led by a man named Peter, also known as Alka or Alka Motors. You can find links down below to the GitHub page and support him on Patreon if you so wish. But because it's open source, there's lots of contributions coming from absolutely everyone in the combat robotics community and the drone community to try and make it better and add new features to it. Unlike its predecessor, BlHeli 32, AM32 was never aimed solely at helicopters or drones or airplanes, and instead it has features built into it for things like RC cars and rock crawlers that need really good low RPM, low end torque performance, something that's very difficult to achieve with sensorless brushless motors that we're all using in combat robots. And that's what makes it an ideal choice for combat robotics use cases like driving a wheel that starts at a dead stop or needs to reverse over and over again, or spinning up a huge steel flywheel with a huge amount of rotational inertia to it. These are both things very far removed from spinning up a lightweight plastic propeller, which is what a lot of other speed controllers that we were using before were optimized to do. As combat robotics has been evolving for many years, we've always been borrowing things from the FPV or quadcopter or drone building communities because they too need things that are extremely lightweight, extremely power dense, extremely efficient, and they don't break the bank when your drone crashes into power lines and sets fire to itself. And with a combat robot, of course, getting destroyed is kind of the aim of the game here, either destroying your opponent or having your own robot get killed in the process of trying. So these things need to be relatively affordable on top of all of those other things, and it's a very hard combination to find in products that are developed out in the wild. Now, I want to say I'm not an expert on AM32. I'm not a software developer or an electrical engineer. I'm a mechanical engineer by trade, and I've learned everything that I know purely by playing around with them myself in experience and watching what videos are out there. But I wanted to try and kind of condense all the information that I know down into this video to make it easier for someone who's just starting out in combat robotics to be able to tune their speed controller to best match their robot and motor and whatever else they're using. But I am no expert. I may get some details wrong about what some specific settings do, so definitely check out some other resources I'll link down below to get the best information you can. I'll also acknowledge this video is being recorded March 11th, 2025, and AM32 is under active development, which means that things will change in the future. If you're watching this video 3 years from now, the latest firmware version is not going to be 2.17, and you should see what the latest version actually is. There may be settings added or removed from the configurator that I show in future versions, so do be aware of that. And in fact, there's already an experimental branch on the GitHub, which I'll also link down below, which has a version 3.x, which has a lot of expanded features and different functionality. I'm going to be focusing on the latest stable version in this video, but I think I'm going to make a future video talking about the CRSF communication protocol used by the experimental AM32 branch because it has some unique advantages for combat that might be worth playing with if you're really comfortable with the technology. But anyway, let's talk a little bit about BlHeli for a second. So BlHeli 32 used to be the predominant firmware used by pretty much all drone builders and stuff. It was closed source, so not open source and community driven, but it had a huge amount of hardware that was running it. BlHeli is no longer supported though because of the conflict between Russia and Ukraine. Around 9 months ago, a letter was circulated online. According to this letter, the company behind BlHeli 32 firmware decided to shut down. It's not entirely clear to me whether they were forced to shut down or did it of their own volition, but either way, due to Norway's strict export control regulations and based on the European Union's legal framework, it was basically impossible for the BlHeli organization to continue operating. It is possible to reflash BlHeli 32 ESCs to AM32. This is an irreversible process, and it will make it so that you can never go back to the BlHeli firmware. You can't do this for every ESC, but there are a lot of them that have been done. However, that process is a little bit convoluted and outside the scope of this video. I've done it. It's pretty painful. I would recommend just buying an AM32 ESC instead. Before I get too far into the meat of this video is not sponsored by anybody, In fact, because I know that these types of tutorial and guide videos don't perform very well on YouTube, I would like to request that if you want to support what I do in releasing more tutorials and guides that get no views initially, but may be helpful to a lot of people searching for them down the line, you could support me on Patreon, link down below, or the QR code you see on screen now. I've had this Patreon for a few months now, but people keep telling me that they didn't know it existed because I forget to mention it in videos, so I'm mentioning it now. Also, of course, I run a web store selling robot parts, including some of the speed controllers you'll see in this video, and there are links down below for that, as well as the GitHub page for AM32 hex files to download if you want to update to the latest firmware for all of the speed controllers I sell, and tons of other really useful information, so make sure to check that description either way. Recorded everything else and forgot to actually talk about how to use the ESCs out of the box. All of the speed controllers I sell are already programmed with some settings that will work for some motors and configurations out of the box. Just depends on which speed controller you get, what that intended use case would be with the out of the box settings, but it's super easy to change them as I'll show in this video. So for example, this is a 35 amp ESC that I sell that I used for my 12-pound robot's drivetrain. So I made sure that it's in bidirectional mode. It's got some 3.5mm bullet connectors I soldered on and an XT30 for power. And then you've got the servo cable with the white signal wire and black ground wire as well. That can plug directly into a motor with 3.5mm bullet connectors like you see here. It doesn't come with those bullet connectors out of the box. It'll look something like this, which is a different receiver, but same deal. So you got 3 pads up here for your motor phase wires. For brushless motors, it doesn't matter which wire goes to which phase pad. If you swap any 2, the motor will switch directions, but you won't blow up the motor by doing the wrong wire to the wrong place. Power wire is very important. Red to your battery positive, black to battery negative. You never want to mix those up. And then again, you've got your white signal, black ground on the servo connector. Soldering to these pads on here, usually pretty easy, but on really big ESCs, you might need a powerful soldering iron. And soldering is pretty much a necessity to use any brushless ESC and motor combo. You'll also find I sell a Pariah 70 amp ESC. This one's more intended for weapon applications, so it comes pre-flashed with bidirectional disabled. But same deal, 3 pads, big power wires. And this has an added capacitor, which I would recommend running if you're running 5S or 6S voltage on your robot. And then I've got the RevvitRC, so this is the one different one. So RevvitRC ESC has a 3rd wire on the servo connector. That is a 7.4 volt or 8.4 volt output to power your receiver. So it's got an onboard voltage regulator to power a receiver or even a servo. So you can set the voltage to either 7.4 or 8.4 volts by flipping that switch that says on or 1. You can check the documentation on my website to see what that does. And then these 3 wires to your motor, again, it just has the wires already soldered on for convenience sake. And again, you've got your thick power wires, red to battery positive, black to battery negative. You could solder an XT30 on here or what have you if you prefer. But this is the only brushless ESC that I sell that has a BEC integrated into it. The other ones you need to power your receiver separately with something like my long all-in-one PD board that has a BEC on here, and then I just soldered a servo pigtail to power my receiver with the red and black wires there. So yeah, out of the box they will work. It's just a matter of, are they programmed to spin in 2 directions or only in 1 direction? So real quick, just show some wiring stuff. So I have here one of the RevvitRC ESCs with an MR30 connector on it to connect to a motor, one of my Blitz Pro drive motors. The RevvitRC comes with these wires pre-soldered, you just have to solder on this connector. Then plug it into the motor. The signal cable is a 3-pin cable. A lot of them will only have a black and a white wire. For signal is white, ground is black, but this one also has a red wire because this guy has a BEC built in that can power a receiver, or in this case a servo tester I'm using as a stand-in for a receiver. And then I soldered an XT30 onto the power leads. So in this case, I'm going to plug it directly into the battery, but in an actual combat robot, you would need a power switch to interrupt power that you could turn on and off. We can see that booted right up, and the motor can now spin as I turn the throttle, essentially. And that's pretty much it. Now, if you're using a speed controller that doesn't have a BEC built in, then it's really helpful to instead use something like my long all-in-one PD board. This makes wiring super easy because it has a BEC built into it right here, and then there is a cable that you can connect to power your receiver. So if you're not using the RevvitRC ESC, and are using any of the other options I sell or any other standard speed controller option, most of them will only have that white and black wire on the servo connector, no red wire to power your receiver. So you connect that to whatever channel on your receiver you want to be controlling for that motor. And then this guy plugs into the PD board, which also has a power switch built into it. This screw is tightened to turn on, loosened to turn off. Right now it's already on though. And then you can plug in your battery. A light turns on the PD board to indicate that it's powered and switched on. And you can see this is lit up because it's already powered. And then again, you can connect this to the motor. And if it was set up properly, this would spin. Yeah, it is actually set up properly, so it does spin. How about that? And if you want to add multiple motors, it's as easy as basically you get another speed controller, another motor, connect them together, add the other speed controller to the PD board, add the other signal cable to your receiver, though in this case, because it's a servo tester, they would all be getting the same signal. And bada bing, bada boom. Now you have 2 motors, or 3 or 4, or however many your receiver will allow and your radio can control. Let's get into diagnosing issues with your AM32 speed controller and beep codes. And then I'll talk about how to adjust the settings on your speed controller, the different USB programmers that are available, and how to use them. All right, I've had to re-record this like 5 times now because either NVIDIA broadcast noise removal is too good and you can't hear the beeping sounds, or I accidentally hit the space bar and stopped recording on OBS. So let's try and get this all real quick in one take here. So we're gonna start with what happens when you plug in your battery, power up your speed controller, but there is not a signal reaching the speed controller. The signal cable is completely unplugged from your receiver. You'll get this same behavior if the receiver just has no power to begin with, and it is plugged in, as you can see here. But if I plug this in, now we get the arming tones. So again, no signal. We get the da-da-da, da-da-da. That is, I have no signal. And then if I shift this off center position, so now it's close to the throttle high, we now are getting calibration mode. So if you power up with the throttle high, it'll enter calibration. Then you want to bring throttle low, and then throttle to center, in this case because it's a bidirectional. And then you've calibrated your throttle range, and now it should spin up normally. So if you wanted to calibrate your throttle range, power up the speed controller with the or connect it to a receiver while the throttle is set high, basically. Instead, if you have a bidirectional programmed speed controller like this, if you connect with it at the center throttle, or once you connect, bring to center throttle, which is 1500 on here, 1000 being low, 2000 being high, and 1500 being center, it should arm. So if, let's say I disconnect, I go to like 1200 and I connect this. So we hear nothing. That means I'm connected to a receiver, but I haven't been given the arming tones yet, and I'm not going to respond to receiver inputs until I'm given the correct arming signal, which in this case is 1500 for a bidirectional speed controller, or would be 1000 for a single direction speed controller. And now we hear that da-da-da, da-da-da, da-da-da. That means it's armed and ready to spin. And for bidirectional, 1500 to 2000 is spin forward, 1500 to 1000 is spin backward, 1500 is stopped. For single direction, it's 1000 is stopped, 1500 is 50% speed forward, 2000 is 100% speed forward, basically. And you can change the direction by either flipping any 2 wires to the motor and speed controller. That will flip which direction it rotates in. So now it's spinning that way or that way. If it's single direction, that will just reverse what one direction it spins in. Or you can also check a box when you're programming it that just says reversed, and that'll do the same thing. Alrighty, let's get into the meat and potatoes of the video. What you really came here for, how to program the settings on your AM32 speed controllers, flash firmware, change it from bidirectional to single direction and back, all that stuff. So I'm going to be showing using a couple different methods for doing this and a couple different programmers. I'm going to start with this guy. So this one I sell on Just Cause Robotics website. It's like $5 or something. Forget what I have it listed for right now. And this is just going to plug into a standard USB port, which is why I have a USB extension on my desk here. And then it's got a 3-pin on the other side to connect to the signal cable on your receiver. I've got a second type here. So this is the RevvitRC 50 amp speed controller, which I recently started selling. And it is using a different, or it comes with a different programmer. It can use either type, but it comes with this one, which is USB-C to 3-pin. So you need an additional cable there, but it works about the same. This one's a little bit nicer just because it's small and compact, and it also has some LEDs to tell you what's going on. And I wanted to show using this just so that you can see what the different LEDs are indicating when you plug things in correctly or incorrectly. So it's because there's no labeling on this one for whatever reason of which side is supposed to get the signal and which side is supposed to get the ground wire. So yeah, let's start with the classic little cheapy guy here. And I'm going to switch to my experimental dual cam setup with the desktop in the background so we can see the online configurator tool. So I've got a USB extension here just so that I could show this on camera. We're going to plug this guy into our computer. Then we've got our ESC. Now, ESC has to be powered when you're programming. So I'm going to connect this guy. And if you look at the bottom of the board, it should say ground. Well, it says GND, NC, and S. So NC just means no connection. S is for signal, and GND is for ground. So we want the white wire for the signal and the black wire for ground. Then I'm going to connect this to power. I like to often just do powered signal connection and then plug in USB, at least for the desktop client. That seems a bit more reliable for me. Now on the AM32.ca website, we're going to go from this main tab to the configurator tab. Select device, no options. Okay, we have to hit port select first. Oh, look, it found one COM device. It's this programmer. And then I'm going to scroll over to the right here and hit connect because my screen is narrow. All right, cool. Now we've got to see all the settings and the firmware that's on here. So this is the programmer the RevvitRC 50 amp comes with, which is right here. So this programmer is USB-C. Very important, you have to make sure you get a USB-C cable that actually has data lines. Some cheap devices that charge over USB-C come with cheap cables that only have 2 wires for power. So you need to make sure you have one that actually has data connection. It'll be pretty obvious because this port select will have nothing in it, or at least won't have your device you actually wanted in it. So we plug this in, we get a green light. That means that this guy is getting power. Now, on our receiver side, we want to power the receiver, and then we're going to connect the signal cable. Now, I'm going to show you the right way and the wrong way. This is the wrong way. If you see the blue LED stable before we've connected to it, that means you plugged this in upside down. So you want to switch it. You want the black wire towards the green LED. And now we are connected the correct way. If we hit port select, choose this guy, hit connect, and then hit connect here, within a couple seconds, we should connect to it and read the data. Now, last time I did this, I had this flipped, and it took forever on this step and never read the data. So hopefully this time it's correct. Although, of course, right now it doesn't want to. Let me try this. Unplug, replug sometimes fixes things. Port select, U, connect, connect. There we go. Okay. Always unplug it and plug it back in if it doesn't work. That's the universal fixes everything rule. All right, I'm gonna do take 2 here on going over what all the different settings mean because I think I fumbled over this a bit the first time. I was a bit too long-winded, so I'm gonna try and do this short, quick, sweet, and go over just the really important stuff here in detail. So first off, probably the most important setting here. I have the web version here on the left. This is actually active and being used. And then on the right here, I just have a screenshot of what the SAM page, or the main page, the settings page on the desktop client looks like for comparison, because this very first thing I talk about is 3D mode. And 3D mode is one of the most important features, and also one that has a completely different name on the desktop client for some reason. In the desktop client, this is bidirectional, or forward reverse. And as the name implies, bidirectional mode allows you to spin your motor both in forward and reverse. If you uncheck 3D mode, which for some reason keeps hiding this, or you uncheck bidirectional mode, that means your motor will only spin in one direction. I showed earlier when I was doing the beep codes, this thing shows the signal being sent to the receiver, or from the receiver to the ESC, essentially. The receiver is sending a pulse width modulated signal with a pulse width between 1000 and 2000 microseconds. So that 1000 and 2000 number is just how wide or how long that pulse is being sent to the speed controller. Now, 1000 to 2000 is the standard range. 1500 is the middle of those. So 1500 is essentially 50% throttle if you're in single direction mode. So if you uncheck 3D mode, uncheck bidirectional, you are 0, 50% at 0 is 1000, 50% at 1500, and 100% at 2000 microseconds, respectively. If you check 3D mode, instead 1500 becomes your 0. That's when the motor is not spinning. Then, as you go from 1500 to 1000, the motor spins increasingly fast in reverse, and if you go 0 to 2000, it spins increasingly fast forward, which, whether this is clockwise or counterclockwise, depends on how you wire your motor. This reverse checkbox will just flip that. So if it's going clockwise from 0 to 2000, it'll switch to counterclockwise from 0 to 2000. But more importantly, if you have 3D mode unchecked, your 1000 to 2000 is only one direction. So let's say it's clockwise, you check reversed mode, and now it is counterclockwise, and it'll only spin counterclockwise when you have 3D mode unchecked or bidirectional unchecked. So that's the most important thing, in my opinion, to go over. And also, unfortunately, confusingly named. Everything else, almost everything else in the web client has the same name as on the desktop client. You'll notice some things are missing on the desktop one because there's this flash tab and this input tab. The input tab has what on the web client is called the servo settings. The servo, it's just called servo settings because the PWM communication I just talked about is like the standard servo communication style. So that is where all those microsecond numbers come in. I like to set it, as you see here, with low 1050, high 1950. This just means if your throttle isn't completely all the way down, it's just a tiny bit off from being down, it'll still have like a 50 microsecond band where it'll act as if it's all the way down. The dead band, I think, does the same thing except at that neutral position. So you'll be able to go, 1525 to 1475 with a 50 microsecond dead band, where it acts as though it's off in the center if you have bidirectional mode enabled. Then we've got the motor configuration tab. So motor stuff is kind of confusingly between the left and right sides on the desktop client. I like how it's laid out in the web client a lot better. So first off, these checkboxes. These are also quite important. Complementary PWM is basically whether braking is enabled or disabled. I know there's another check for braking down here. I don't know why, but if you uncheck complementary PWM, then it'll ignore all of these settings under brake, and you won't have any motor braking. Variable PWM, I always just leave on, and it just adjusts what PWM frequency is sent to the ESC. 99.9% of the time, this will not matter for you, and you don't need to touch this. Just leave variable PWM on. The Hall sensors checkbox does nothing. It's not properly implemented. Stall protection and stuck rotor protection. These sound like the same thing, but they are very different and also very badly named, in my opinion. So basically, never check stuck rotor protection for a combat robot. Stuck rotor protection is for when a propeller on a drone strikes a tree branch or something, and then it's having some resistance trying to spin up, and this will basically make it so that it doesn't even try very hard to spin up. This is the exact opposite of what you want for a combat robot. Like if you have a tiny bit of dent in like your gearbox housing and it has to overcome a bit of resistance to get your wheel spinning, you want it to get the wheel spinning. So you should always uncheck this, rather. You should always take that off. Stall protection, on the other hand, is more so like if your wheel is completely locked up and the motor's being given all the beans and the wheel absolutely will not start spinning, it'll limit how long it gives the full beans to the motor so that it doesn't blow up the motor or the speed controller. So I usually check this on. If for some reason you need the absolute last drop of power that your speed controller can produce, then you can uncheck this. And you would also, in that case, want to uncheck everything in the limits page. So the limits page, personally, I think temperature limit is fine to leave enabled. Pretty much every speed controller will have temperature sensors that function properly. And usually you'll want it between 120 and 140 degrees Celsius, but you can disable it if you would like. Solder reflows at 188 Celsius, so that's partly why it doesn't go above 140 and just goes to disabled, because you're going to be able to permanently damage your ESC if it's not throttling the power sent to the motor beyond that point. The current limit. This is somewhat self-explanatory, but it doesn't work quite the way you might think it does. It's not like this is a 100% definite hard cap. It will never go to 40.001 amps if you set it to 40, because the polling rate of the sensor isn't that amazing. But if you set the current limit to 40, you're not going to have extended periods of time at which the speed controller is pushing more than 40 amps. Also, keep in mind, not every speed controller has a working current sensor, or one that's tuned properly. This is especially an issue with AM32 ESCs, because a lot of them used to be BlHeli 32 ESCs that are flashed with AM32 firmware, but they don't always have the correct offsets for the exact hardware on that board. So sometimes the current limit will think that it's at like 50 amps, but it actually would permit 75 amps through because the offset's not set properly or something like that. I know the Pariah 70 amp that I sell, the current sensor doesn't work properly on that one. The RevvitRC ESC, the brand new one I just started offering, does have a working proper current sensing. The HackRC ESC does not have a working current sensor, and if you try to set a current limit, it'll just act as if it's disabled. And I think the 35 amp, this guy, I believe this one does have current sensor on it, but I'm not sure if it's tuned properly. I always just run these with the current sensing disabled. I've never had a problem with them killing my motors or themselves personally. They usually will just thermal throttle from the temperature limit before that point. Now, low voltage cutoff threshold. This one's controversial. A lot of people will say just turn this off all the time for a combat robot. Personally, for weapon applications, I like to leave this on at around 3.3 volts per cell, which is that 330 you see here. And at 3.3 volts per cell, you've got a tiny little bit of juice left for your drive to keep working if the weapon cuts out because your battery voltage is too low, and that can get you the last 20 seconds to the end of a 3-minute match in some cases with functioning drive. So personally, I like to have that, but obviously not everybody has the same opinion, and you can't always just disable it. Yeah, let's get into a little bit of these sliders here in motor as well. So your timing advanced. Pretty much don't want to have this below 15. Some motor manufacturers post exact values to use, in which case you may as well use that exact value. But the higher this is, the lower there is a chance of your motor just not spinning up. Startup power. Basically, you can't really go too wrong here. This only affects the motor when it's at like really low RPM. But if you run it really low and your motor's not spinning up, then just raise it. Somewhere between 100 and 150 is typically what I'll have it at. But it doesn't make as big of a difference as the name might imply. It's not going to make it so that your motor spins up like 50% faster if you run it at 150. That just won't happen. Motor KV, you want it to match your motor, not too hard. Motor pulls, you'll want it to match your motor, not too hard. If you don't know what your motor pull count is, most outrunners are going to be 14 pulls, or maybe somewhere between 10 and 14 pulls. If you have like a gigantic motor or something, like maybe check the specs page for your motor. The store pages likely have that kind of information somewhere. And if you're running an in-runner, this is very important. The pull count's usually like 2 or 4, so that's where it's more important to change this. Both the motor pull count and the motor KV numbers are mostly just used to prevent desync from your motor at low RPM. And sometimes if you set the KV like way too low, it won't let your motor spin up to its maximum RPM. So you're going to want to try and match that to your motor as best you can, but it's not going to explode if it's wrong. Beep volume. I personally find the AM32 beeping to be pretty quiet, so I usually run this at 10 or 11. And some people have said that if it's really high, it can damage your motor, but I've never even noticed my motor's getting even slightly warm from this. So I don't think that's a real issue personally. And again, PWM frequency, if you have variable PWM on, you just don't bother touching this. All right, braking and sinusoidal. So sinusoidal, for pretty much every combat application, you want this turned off. It gives your motor a bit of extra oomph at the expense of generating a lot of extra heat at really low RPM. And typically you won't want that for a combat bot. It's mainly used for RC rock crawlers that are operating at like low hundreds or even tens of RPM on the motor. Brake and brake on stop. This is a big difference between drive and weapon applications. If you're running a drive application, you probably want to turn on complementary PWM, turn on brake on stop, and set the running brake to something. other than 1. So basically, if you check brake on stop, then this brake strength dial affects it. If you have running brake set to something other than 1, then running brake is also in effect. The only difference between these is brake on stop is going from whatever speed to 0 speed. And running brake is going from whatever speed to whatever speed that's lower than that, but not 0 speed. So going from 100% to 50%, 50% to 20%, that is where your running brake is taking effect. Going from 20% to 0, 100% to 0, 50% to 0, that is where your stopped brake takes effect. And most importantly, when you're on a drive motor, if you're reversing the motor direction, that is going to be your brake on stop till it gets to 0, and then it'll be accelerating from there in the opposite direction. So I would strongly recommend you put a fairly high brake strength on your brake on stop. And running brake, you can kind of adjust by feel. Both of these you really should adjust by feel based on what your preferences are. Some people like it when their motors keep coasting when they let off the stick. Others want them to stop immediately and be more responsive. I would say the same thing kind of goes for startup power in the opposite direction, trying to speed up afterwards. That's where you can play around with startup power. If you want it to be lagging behind your inputs a tiny bit, maybe you want lower startup power and maybe even lower timing, but realistically, you probably want to try and adjust those things in your radio rather than on the speed controller, because you don't want the speed controller to be limiting what you're capable of doing and not be able to change that on the fly in the middle of a fight by just pushing the throttle stick further or whatever. So yeah, I think that covers everything here other than the flashing. So let's go to firmware flashing. So if you want to flash a new firmware to your speed controller to update it, you can just hit flash firmware, and on the web client, it'll recognize what hex file's on there now and tell you if you want to go to whichever version, which hex file should be loaded. It looks like there isn't a V2.16 for the Rhino for whatever reason, but there is a 2.17. You can also check pre-release versions if you want or whatever. So yeah, you can also choose a different hex file if you want to and ignore the MCU layout, but I don't know why you would want to do that unless you're like developing a firmware file for a brand new speed controller or a custom one. So yeah, and then you just hit start flash. It takes a while. I showed this in a previous recording and I can show how long that took on screen. If you got a speed controller with like version 1.99 and you want to update to 2.17, go for it. But if the speed controller works for you out of the box, there aren't like new features being added in these new versions. It's just mostly minor tweaks and changes here in the version 2.17 and below. However, there are some fixes for specific processors that had bad behavior. So you'll see like the FO51 here, that refers to the processor that's on board this speed controller. Two of the most common ones are FO51 and I think it's Geo47, Geo57, something like that. I know that the Neutron RC 70 amps, there's been reports of that processor with the Geo whatever it is misbehaving with AM32 sometimes. So something to keep in mind when you're shopping for a speed controller. If you want to save configs, like you have 2 drive ESCs and you just saved your profile for one of them and you want to upload the same profile to another, or you just have spare speed controllers, for instance, like if I want to set this to be a weapon one, I'll turn off the braking again, and then I can hit save config and then download. Save this to my desktop, ESC config 1, sure, save. And then I can hit apply config to pull it back up, open, and apply to EST1. And you can see it changed some stuff because I had saved it previously with different settings. So yeah, that's a nice easy way to make it so that you have your settings for your drive speed controllers, your setting for your weapon speed controller easily accessible, and you can just flash another speed controller with those same settings to get them all to be the same. There's also this tune tab here. This lets you do startup music. You'll have to like Google like BlHeli tunes and paste something in. It's got like some weird esoteric thing for melodies for that, but you can hypothetically do startup tones just like you could with BlHeli on AM32 using this. So yeah, I think that covers pretty much everything on the web side. The desktop client side, I would recommend downloading the desktop client just in case you need to change settings at a competition, because there's no guarantee you're going to have a good Wi-Fi connection at a competition. But the desktop client, it's mostly the same. Like I said, like the bidirectional is renamed from 3D mode, but it's pretty much the same for everything. There are some extra things on the desktop client for the 1.82 anyway, like 30 ms telemetry. For some reason, no checkbox for that on the web version. I'm not sure if that's even fully implemented. Hall sensors is a checkbox that isn't fully implemented on either one, and stuff like that. However, there is one case where you definitely need the desktop client, and that is if you're trying to do stuff with the experimental branch of AM32. I think I'm going to cover that in a future video when I also talk about ELRS receivers, because basically in my mind, the one huge benefit that you can get from using ELRS receivers with AM32 speed controllers is using the experimental firmware for a communication method known as CRSF. I won't talk about it too much right now, but essentially it just lets you use a single wire to communicate with up to like 12 ESCs from a receiver instead of needing like a huge web of separate PWM cables with a ground and a signal from each one. And it also works nicely for 4-in-1 ESCs because of that. But yeah, that is a topic for a future video. So yeah, I think that pretty much covers everything that I wanted to communicate today about AM32 firmware. Like I said, I will do a follow-up video at some point, a month or two from now, once I've caught up on event recaps, talking about using some advanced features in the experimental version. But for right now, I think that should cover what 99% of bot builders really need to get started on their combat robot journey using AM32 speed controllers. And of course, if you want to buy some that are pre-programmed out of the box for different applications, just check my website below to get motors and speed controllers matched to each other that should work perfectly out of the box without needing to futz with the settings at all. So if you like this video, click like, make sure to subscribe and hit the bell if you want to see more like this in the future, and thank you so much for watching.